Hello, everyone. Right now, we're going to be taking a look at problems 13 and 14 from the textbook. This is from section 13.4, set A. I'm going to go ahead and bring up the PowerPoint to share with you. Here it is. You can't see that. Okay. Now you're able to see the PowerPoint. I'm going to go ahead and start the slideshow. So again, we're going to be looking at problems number 13 and 14 from the textbook. We're going to start with problem number 13. It says find the volume of each of the following solid figures rounded to the nearest cubic inch. We're going to start with part A, which is this shape right here. And this shape is a prism. It's a little unusual, but it does have two identical bases. So the base is this end here, and there's another copy of it at the other end. And to find the volume of a prism, we will multiply the area of the base times the height. And the base is a rectangle, which is 9 inches by 8 inches. Well, it's almost the whole rectangle, but it's missing an equilateral triangle. And all three sides of that equilateral triangle are 3 inches. To find the area of the base, we'll take the area of the rectangle minus the area of that triangle that's cut out. The area of the rectangle, that one's pretty easy. We're going to multiply length times width, so 9 inches times 8 inches. And that will give us 72 square inches. Looks like someone has joined us. Did you have any questions so far? Okay, well, welcome. We are recording, and we just started looking at problem number 13. We're looking at part A. And we're finding the volume, so we're going to take the area of the base times the height, and we need to figure out the area of that base. So we're going to do the area of the rectangle minus the area of the triangle. We just found out that the area of the rectangle is 72 square inches. To find the area of the triangle, we'll use the formula 1/2 base times height. And we know the base is 3 inches, so I've made a little drawing of that triangle down here. It is an equilateral triangle, and the base is 3 inches, and we need to figure out what the height is. We don't know that yet. To find the height of the triangle, I looked at this right triangle here, which I got by just drawing a line up and down, and we know that the hypotenuse is 3 inches, and this leg of the right triangle is 1.5 inches. So we use the Pythagorean theorem, a squared plus b squared equals c squared, where c is 3 inches. And if you do that, you'll find that the height, h, is the square root of 6.75. And I simplified that. 6.75 is 3 times 2.25. And so we have the square root of 2.25 times the square root of 3. The square root of 2.25 is 1.5. And I see that you have a question. What's your question? Oh, nope, you didn't have a question. You didn't raise your hand. All right, just imagining things. Okay. So we now know the height of that little triangle. And to find the area of the triangle, we're going to do, again, 1/2 base times height, where the base is 3 inches, and now we know the height is 1.5 times the square root of 3, and this gives us 2.25 times the square root of 3 square inches. And that's the area of the triangle. To find the area of the base, we'll take the area of the rectangle minus the area of the triangle. Remember, we found the area of the rectangle before. And so we have 72 square inches, that's the area of the rectangle, minus 2.25 times the square root of 3 square inches. And I just grabbed my calculator and punched that in. and I found that was 68.103 square inches. Okay, we're not quite done. We're trying to find the volume. We know the area of the base now. To find the volume, we multiply the area of the base times the height. We found the area of the base was about 68.103 square inches, and the height of the prism, that's the 8 inches. So we multiply those together, and it comes out to be approximately 545 cubic inches. Okay, next, we're going to take a look at part B. For part B, we're looking at this picture, and we're trying to find the volume. So to me, this kind of looks like a bowl or the rind of an orange or maybe like a watermelon or something. And to find that volume, we'll find the volume of the outer, larger hemisphere, and we'll subtract the volume of the smaller inside hemisphere. The volume of a sphere is 4/3 pi r cubed. So to find half of a sphere or a hemisphere, we'll multiply that by a half, and the 2 and the 4 cancel, so we end up with 2/3 pi r cubed. And we know the diameter of the larger hemisphere. The distance all the way across is 9 inches. So that means that its radius is half of that, which is 4.5 inches. So the volume of the larger hemisphere will be 2/3 pi r cubed. We know the radius is 4.5 inches. And so I punched that into my calculator. I got 60.75 pi cubic inches. And then for the smaller inside hemisphere, I took 2/3 pi r cubed, and this time the radius for the inside one was just 3.5 inches, and this came out to be 28.583 repeating pi cubic inches. And then next I want to subtract them. I'll take the larger outer hemisphere minus the inside one, and that kind of gives me the volume of the rind of this watermelon or whatever we're thinking it is. So we'll take the volume of the larger hemisphere minus the volume of the smaller one. And the outer one, remember, was 60.75 cubic inches. The inner one was 28.583 repeating cubic inches. When I subtract, I get 32.16 repeating pi cubic inches. And that's approximately 101 cubic inches. Any questions on any of that so far? Okay, next we're going to take a look at problem number 14. It says a standard tennis ball can is a cylinder that holds 3 tennis balls. Which one is greater, the circumference of the can or its height? And then part B, if the radius of a tennis ball is 3.5 centimeters, what percent of the can is occupied by air, not including the air inside the balls? So here's my picture. This is my 3 tennis balls, and just imagine that they're inside of a cylinder. So for part A, we don't know the radius, so let's just say that the radius of each ball is r units. Then the diameter of each ball is 2r. Okay, to get the diameter, we just double the radius. And since we have 3 balls lined up, the height of the can is the distance across 3 balls. So 3 balls, and the distance across each ball is 2r. And that tells me that the height of the can is 6r. To find the circumference of a circle is 2 pi r, and that gives me approximately 6.28 times r. And so I can see that the circumference is just a little bit bigger than the height of the canister. Next, we're going to take a look at part B. To figure out the volume of air, we'll take the volume of the can minus the volume of the 3 balls. To get the volume of the can, because that's a cylinder, we take the area of the base times the height, and the base is a circle, so its area is pi r squared, so we have pi times 3.5 inches squared. So in part B, they told us the radius was 3.5 inches. And then we multiply that by the height, and we just found out that the height was 6 times the radius, so 6 times 3.5 inches. And I punched this into my calculator, and I came up with 257.25 pi cubic inches. To find the volume of the 3 balls, I'm going to take the volume of a sphere and multiply that by 3. And the volume of a sphere is 4/3 pi r cubed. I've gone ahead and plugged in the radius is 3.5 inches. And this comes out to be 171.5 pi cubic inches. To find the volume of air, I'm again going to take the volume of the can minus the volume of the 3 balls. So 257.25 pi cubic units minus 171.5 pi cubic units. And that comes out to be 85.75 pi cubic units. So now I've figured out the volume of the air. On the last slide, I found the volume of the can. And now to figure out what percent of the can is occupied by the air, we can just set up a proportion. So I can do the volume of the air over the total volume of the can equals x over 100, right? So it's part over whole. And then I multiply to figure out what x is. And I find out that x is equal to 33.3 repeating percent. So in other words, it's saying 1/3 of the can is occupied by air, which means that 2/3 is occupied by the tennis balls. And that brings us to the end of the PowerPoint. So I'm going to stop sharing the PowerPoint. Okay, and I'm going to go ahead and turn off the recording